Good morning, students. Today we are going to see crystal physics. ஸோ கிறிஸ்டல் ஃபிசிக்ஸ் அப்படிங்கிறது உங்களுக்கு வந்து யூனிட் 3ல இருக்கு. ஸோ யூனிட் 3ல நம்ம கிறிஸ்டல் ஃபிசிக்ஸ் அப்படிங்கிற டாபிக் வந்து என்ன செய்ய போறோம் அப்படின்னா பார்க்க போறோம். ஸோ இந்த த அவுட்லைன் ஆஃப் த லெக்சர் இஸ் இன்ட்ரோடக்ஷன் ஆஃப் கிறிஸ்டல் ஃபிசிக்ஸ், கிறிஸ்டலைன் அண்ட் நான் கிறிஸ்டலைன் சாலிட்ஸ்னா என்ன, ஸ்பேஸ் லாட்டிஸ்னா என்ன, வாட் இஸ் மீன் பை கிறிஸ்டல் ஸ்ட்ரக்சர், தென் lattice parameters, crystal system. There are 7 crystal systems are available. Then Bravais lattice. There are 14 Bravais lattice are available. So we are going to see one by one. First we are going to see introduction to crystal physics. So in that we are all know that the matter can be classified into 3 types: solid, liquid and gases. So solid means any solid material. So this is the solids. So liquids, these are the liquids. So gas materials, these are the gas materials. So matter can be classified into 3 types: solids, liquid and gases. In that, what is crystal physics? Before going that, what is crystal physics? Why we are going to study crystal physics? Because all the physical properties of the solids can be determined from the crystal physics. So crystal physics means the physical properties of the crystalline solids. Here we are determine their actual structure of the solid by using X-rays, neutron beams and electron beams, etc. So the structure determination by using X-rays, neutron beams and electron beams. So the solids can be classified into, solid materials can be classified into 2 types: crystalline solids and non-crystalline solids. In that crystalline solids, all the atoms are arranged in periodic manner. But in the case of non-crystalline solids, otherwise called as amorphous solids, in that non-crystalline solids, atoms are not arranged in a periodic manner. So I have given diagram for some crystalline solids and amorphous solids, non-crystalline solids and polycrystalline solids. Now we are going to see one by one. First, crystalline solids. In that crystalline solids, I already told you that all the arrangements of atoms in regular or periodic. There is a periodic arrangement of atoms. So this is the periodic arrangement of atoms. All the atoms are arranged in a periodic manner. These crystalline solids are anisotropic substance. They are having the sharp melting point. So the melting point of crystalline solids are very sharp. They possess a regular shape. So the shape of the crystalline solids are regular. Examples: iron, copper, carbon, germanium. So these are the examples for crystalline solids. The non-crystalline solids are otherwise called as amorphous solids. Here the particles are randomly distributed. But in the case of crystalline solids, atoms are arranged in a periodic manner. All the atoms are arranged in periodic manner. But here all the particles are arranged in randomly. They are distributed in randomly. They are isotropic substance. But in the case of crystalline solids, they are anisotropic substance. They have sharp melting point, crystalline solids. But in the case of non-crystalline solids, have wide range of melting point. The examples for non-crystalline solids are glass, plastic, rubber, etc. So these are the examples for non-crystalline solids. Next one, polycrystalline solids. So this is the example for polycrystalline solids. Here the polycrystalline solids having the grain boundaries. In that grain boundaries, all the atoms are arranged in periodic. Each grain atoms are arranged in periodic manner. So the grains having the size in the range of 100 nanometer to 100 microns. So the polycrystalline grains with less than 10 nanometer in diameters are nanocrystalline. Suppose if I consider the one polycrystalline material with the grain size is 10 nanometer in diameter which are called as nanocrystallines. The examples are inorganic solids, most of the metals and ceramics. So these are the polycrystalline solids. So we are know what is crystalline solids and non-crystalline solids. So in your exam they may ask what is the difference between crystalline solids and non-crystalline solids. So you must write. Then we are going to see what are the crystallographic terms. Before going that, some of the crystallographic terms are important. You must know what are the crystallographic terms. In that, first one is space lattice, second one lattice points, third one lattice lines, then lattice planes, then basis or motif, then crystal structure, then very important unit cell, then lattice parameter. These are the crystallographic terms you must know before studying the crystal physics. So first one, space lattice. Before going the space lattice, what is mean by lattice? So lattice is a imaginary point. Lattices are imaginary points which represents the position of atoms in the crystal. So a lattice is an imaginary points. So it nothing but imaginary points which represents the position of atoms in the crystals. So what is the position of the atom in the crystals? So space lattice means there is the regular and periodic arrangement of point in 3 dimension. If we see in 3 dimension, all the atoms are arranged in a periodic. All the points are arranged in a periodic manner. If we called, it is called as a space lattice. If we see the surroundings of the all atoms, all the surroundings are identical in nature. So identical surrounding to that of every other point in an array. Suppose if we consider one array, if we see the surroundings, all the atoms are identical. So they are having the identical surroundings. So this is called a space lattice. Second one, basis. So we are all know that what is lattice. Lattice is an imaginary point which represents the position of atoms in a crystal. So basis is a unit assembly of atoms or molecules in identical composition. So suppose if I consider the aluminium crystal, the number of atoms in a basis is 1 because the aluminium is 1, only one aluminium atom. Suppose if I consider the barium crystal, the number of atoms in basis is 1. So basis represents the group of atoms. That is the unit assembly of atoms in a lattice. Okay. So suppose if I consider NaCl crystal, sodium chloride crystal, there are 2 atoms are present in the basis. First atom is NaCl, first atom is Na, second atom is Cl. Suppose if I consider KCl crystal, first atom is K, second atom is Cl. So there are 2 atoms. Okay. So the repetition of basis correct periodicity in all direction. The crystal structure is real while the lattice is imaginary. So lattice is the imaginary points. Lattice point is the imaginary points which represents the position of atoms. This lattice and basis gives the actual crystal structure. லாட்டிஸும் பேசிஸும் சேர்ந்தது தான் வந்து என்ன அப்படின்னா crystal structure. Lattice plus basis gives the crystal structure. So this is the diagrammatic representation of crystal structure. So this is the imaginary points. So lattice points. This is basis. Basis is group of atoms. So if we add these two, lattice plus basis, we will get the crystal structure. So this is the crystal structure. Then next one important property, next one important term, unit cell. Unit cell is a fundamental building block of a crystal. So ஒரு crystal எடுத்துக்கிட்டோம் அப்படின்னா அதோட fundamental building block என்ன அப்படின்னா unit cell தான். So repeating its own dimension in various directions. So if we see all direction, any direction, the repetition will be same. அதான் ஒரு எக்ஸாம்பிள் சொல்லுவாங்க. Suppose if I consider one wall, all the bricks are known as a unit cell. இப்போ ஒரு வால் எடுத்துக்கிட்டோம் அப்படின்னா அதில் இருக்க ஈச் பிரிக் செங்கல் இருக்குல்ல அந்த ஒவ்வொரு செங்கலும் வந்து என்ன அப்படின்னா ஒரு யூனிட் செல் அப்படின்னு சொல்லி என்ன செய்வாங்க அப்படின்னா சொல்லுவாங்க. The next one, lattice parameter. Suppose if I consider one crystal, so this is the cubic crystal. Okay, so the length of the unit cell along x, y, z axis directions are a, b, c. So along the x direction it is a, along y direction it is b, along z direction is c. Okay, so this a, b, c are called the lattice parameters. Then alpha, beta, gamma are called as the interfacial angle or the interaxial angles. So the alpha is the angle between A and B. This is the A, this B. The alpha is the angle between A and B. Beta is the angle between B and C. Beta is the angle between B and C. Gamma is the angle between C and A. This alpha, beta, gamma and A, B, C are collectively known as the lattice parameter. So the lattice parameters are A, B, C and alpha, beta, gamma. So based on the alpha, beta, gamma and A, B, C, we are grouped in the crystal system into 7. We are classified the crystal system. There are 7 crystal systems are available. Next we are going to see one by one. Then before that, what is meant by primitive cell? Primitive cell, if the number of atoms per unit cell is 1, primitive cell means the number of atoms per unit cell is 1. A unit cell consists only one full atom. Then the unit cell is called as the primitive cell. Example for primitive cell is simple cubic. Simple cubic na enna அப்படிங்கறத நம்ம என்ன செய்யலாம் அப்படினா பின்னாடி பார்க்கலாம். The non primitive cell, if the unit cell consists of more than one atom, if the unit cell consists of more than one atom, then the unit cell is called as the non primitive unit cell. So the example for non primitive unit cell is body centered cubic and face centered cubic unit cell. So these are the primitive unit cell and non primitive unit cell. Now we are going to see what are the 7 crystal systems. There are 7 crystal systems are available. First one cubic, second one tetrahedral, third one orthorhombic, fourth one rhombohedral, fifth one hexagonal, sixth one monoclinic, seventh one triclinic. We are classify this crystal system, 7 crystal system based on the values of lattice parameters A, B, C and alpha, beta, gamma. If the A is equal to B is equal to C, all the axial distance A is equal to B is equal to C and the interfacial angle alpha, beta, gamma is equal to 90 degree means then the crystal system is said to be a cubic crystal. So cubic crystal means A is equal to B is equal to C. Tetragonal means A is equal to B but not equal to C. A வும் B யும் ஈக்குவலா இருக்கும். So அதனால தான் A ஈக்குவலா போட்டுருப்பாங்க, which is not equal to C, but the alpha, beta, gamma is equal to 90 degree. Alpha, beta, gamma is equal to 90 degree. In the case of orthorhombic, A is not equal to B is not equal to C. All the axial length will not equal for the case of orthorhombic, but alpha, beta, gamma is equal to 90 degree. Then rhombohedral means A is equal to B is equal to C, alpha is equal to beta is equal to gamma. All the angles are equal. Alpha is equal to beta equal to gamma. All the angles are equal, but it is not 90 degree. So 90 degree கிடையாது. Hexagonal A is equal to B but not equal to C. A is equal to B but not equal to C. Alpha, beta is equal to 90 degree. Alpha, beta is equal to 90 degree. Gamma is equal to 120 degree. Gamma is equal to 120 degree. Monoclinic, all the axial length are not equal. A is not equal to B is not equal to C. Alpha is equal to gamma which is equal to 90 degree. Alpha, gamma is equal to 90 degree but which is not equal to beta in the case of monoclinic. Then triclinic, A is not equal to B is not equal to C. alpha is not equal to beta is not equal to gamma is not equal to 90 degree. Okay, so these are the 7 crystal system. These 7 crystal system can be classified based on the values of a, b, c and alpha, beta, gamma values that are grouply known as lattice parameters. So already we are known. Okay, so this is the table which describes the lattice 7 crystal systems and its lattice parameters values. So we already discussed in last column the number of lattice in the system. Number of lattice, how many Bravais lattice are available for the system. In the case of cubic there are 3 Bravais lattice are available. In the case of tetragonal 2, orthorhombic 4. That means cubic means there are 3 Bravais lattice. First one simple cubic, body centered cubic, face centered cubic. So these are the 3 Bravais lattice. So similarly in the case of orthorhombic, simple orthorhombic, body centered orthorhombic, face centered orthorhombic, base centered orthorhombic. Monoclinic, simple monoclinic, base centered monoclinic. So these are the Bravais lattice for all the crystal systems. If we add this all the lattice system, number of lattice in the system, we will get the value 14. 3 plus 2, 5, 9, 11, 12, 13, 14. We get the 14 Bravais lattice. We get 14 Bravais lattice. These are the 14 Bravais lattice. So it is sold by Bravais in 1948. Only the 14 types of unit cell under 7 crystal systems are possible, which are known as a Bravais lattice. So if we consider the simple cubic means in all the there are 8 corner, in each corner 1 atom present. Totally there are 8 corner atoms. If we consider base centered cubic, at each corner 1 atom available, 8 corner atom at each face. So we are all know that the cubic crystal has 6 face. So at each face 1 atom is present. Body centered cubic, at the center of the cube 1 atom is present. That atom is called as the body centered atoms. Okay, then at 8 corner there are 8 atoms are available. So then next one, simple tetragonal, body centered tetragonal. There are 2 Bravais lattice for tetragonal, simple tetragonal and body centered tetragonal. Hexagonal only 1 Bravais lattice. Then orthorhombic 4 Bravais lattice are available. Simple orthorhombic, body centered orthorhombic, base centered orthorhombic, face centered orthorhombic. Rhombohedral, simple rhombohedral are available. Then monoclinic, simple monoclinic and base centered monoclinic. So already I told simple monoclinic and base centered monoclinic. In the case of triclinic, only the simple triclinic is available. So these are the Bravais lattice. There are 14 types of unit cell under 7 crystal systems are possible. So this is the table which shows the Bravais lattice. So this for cubic, for example cubic crystal, simple, body centered and face centered. Only 3 Bravais lattice are available. So P represents the primitive, I represents the body centered, F represents the face centered, C represents the base centered. Primitive means simple. So this is the table which represents the Bravais lattice, divided into 7 crystal systems. Okay, so this is very important question. 7 crystal system, draw the Bravais lattice for these 7 crystal systems, very important. Next we are going to see characteristics of a unit cell. So what are the characteristics are the unit cell? Suppose if I consider one unit cell, what are the characteristics are available? First characteristics is number of atoms per unit cell. What is mean by number of atoms per unit cell? The total number of atoms present or shared by an unit cell is called as number of atoms per unit cell. Then next, second characteristics, coordination number. Number of nearest neighbor atom to a particular atom. Suppose if we consider the simple cubic system, consider one atom which with in that atom is a particular atom. there are number of nearest neighbor are available. There are several number of nearest neighbor are available. That how many number of nearest neighbor are available is known as the coordination number. And then atomic radius. Atomic radius represents the half of the distance between any two nearest neighbor atoms which have direct contact with each other. Half of the distance between any two nearest neighbor atoms which have direct contact with each other is called the atomic radius. Then atomic packing factor. So atomic packing factor அப்படினா வந்து ஃபார்முலா இருக்கு, ஏபிஎஃப் கண்டுபிடிக்கிறதுக்கு ஃபார்முலா இருக்கு. So the how the atoms are packed in the structure. So APF formula என்ன அப்படின்னா APF is equal to number of atoms per unit cell into volume of one atom divided by total volume of the unit cell. So this is the formula to calculate the atomic packing factor. Now we are going to see one by one for simple cubic structure characteristics of unit cell என்னென்ன, body centeredக்கு என்னென்ன, face centeredக்கு என்ன, ஹெக்ஸாகனலுக்கு என்னென்ன அப்படிங்கிறத என்ன செய்வோம் அப்படின்னா அடுத்து வர்ற கிளாஸஸ்ல என்ன செய்யலாம் அப்படின்னா ஒன் பை ஒன்னா பார்க்கலாம். ஸோ திஸ் இஸ் த பேசிக் கிளாஸ் ஃபார் கிறிஸ்டல் பிசிக்ஸ். கிறிஸ்டல் பிசிக்ஸோட பேசிக் கிளாஸ் தான் நம்ம என்ன செஞ்சிருக்கோம் அப்படின்னா படிச்சிருக்கோம். ஸோ என்னென்ன படித்தோம் அப்படின்னா ஸோ கிறிஸ்டல் பிசிக்ஸோட இன்ட்ரோடக்ஷன் என்ன, கிறிஸ்டலைன் சாலிட்ஸ்னா என்ன, நான் கிறிஸ்டலைன் சாலிட்ஸ்னா என்ன, ஸ்பேஸ் லாட்டிஸ்னா என்ன, லாட்டிஸ்னா என்ன, பேசிஸ்னா என்ன, அதிலே லாட்டிஸ்னா என்ன, பேசிஸ்னா என்ன, தென் வாட் இஸ் மீன் பை கிறிஸ்டல் ஸ்ட்ரக்சர், கிறிஸ்டல் ஸ்ட்ரக்சர்னா என்ன, ஸோ லாட்டிஸ் பேராமீட்டர்ஸ்னா என்ன, என்னென்ன கிறிஸ்டல் சிஸ்டம்ஸ் ஆர் அவைலபிள், தென் பிரேவியஸ் லாட்டிஸ்னா என்ன அப்படிங்கிறத நம்ம என்ன செஞ்சுருக்கோம் அப்படின்னா பார்த்துருக்கோம். ஸோ அதில் லாட்டிஸ்ன்னு சொல்லி பார்த்தோம் அப்படின்னா லாட்டிஸ் இஸ் ஆன் இமேஜினரி பாயிண்ட்ஸ் விச் ரெப்ரசன்ட்ஸ் தி பொசிஷன் ஆஃப் ஆட்டம்ஸ் இன் த கிறிஸ்டல். So basis means the unit assembly, that is the group of atoms in the lattice. So lattice plus basis gives the crystal structure. latticeum basisum சேர்ந்தது தான் என்ன அப்படின்னா crystal structure அப்படின்னு சொல்லி சொல்லுவாங்க. Then lattice parameter அப்படின்னா என்ன அப்படின்னா suppose if I consider the one unit cell, so the axial length, for example in x axis the axial length is a, the y axis the axial length is b, in z axis the axial length is c. See the all ABC is called the lattice parameters. ABC is called the lattice parameter. Then the angle between A and B is alpha, angle between the B and C is beta, angle between C and A is gamma. This alpha, beta, gamma and A, B, C are collectively known as the lattice parameter. This is the lattice parameter. Based on the values of ABC and alpha, beta, gamma, and the crystal systems are classified into 7 types. There are 14 previous lattices are available. Okay, thank you students.